Okay, we're heading into the graphing segment of intermediate algebra, and just wanted to sort of refresh your memory on concepts that you've had in the past, I'm sure. So you recall this is the x-axis and the y-axis, so we're reintroducing you to the rectangular coordinate system. You probably recall that the quadrants go 1, 2 counterclockwise, 3, and 4, right? You probably recall that this point here, where the two axes meet, is origin, okay? And in a moment, we're going to be doing a lot of graphing of various different kinds of equations, but for starters, let me flip to the next slide. My top 3 questions as we head into this graphing segment. Things that people always ask me. Okay, number 1. How do I graph linear and nonlinear equations? Well, now we're at the level, basically, this is where the sort of the C parts. Some people are going to use their TI-83. Now, it doesn't mean that they really know what they're doing. They could be just plugging things into a calculator and hoping that it's right. But it is a crutch, so that's option 1, TI-83. There's also a great website and an app on the iPhone or any phone, Wolfram Alpha. So you can use a Wolfram Alpha to help you graph various equations. But the best way, I'm going to put a big star, is good old-fashioned by hand. And that's what we'll focus most of our time on. Okay? Number 2, how do I identify x and y intercepts of an equation? So if I throw you an equation, whether it's linear or nonlinear, will you be able to find the x and y intercepts? And we'll explore all these things in a moment. And number 3, how do I perform the following calculations? Slope, distance, and midpoint. So how do I calculate the slope of a line between 2 points? How do I calculate the distance between 2 points in space? And how do I calculate the midpoint of a line segment? And then, of course, actually nested within that is how do I actually write equations of, write equations of lines given various information about the line. So, all right, let's get started with number 1. How do I graph linear and nonlinear equations? Well, before you do that, you really have to understand, what is linear versus nonlinear. So let's just give you some, let me switch back to my black pen there. Let's just give you some light examples, okay? We said, big note to self, linear was just a fancy word for first degree. Examples, 2x plus 3 equals 9. Well, the highest power of the variable x is 1, so that's first degree. All right, how about 2x minus 8y equals 12? Well, that's first degree because the highest power of any variable in the equation is 1. Okay, how about just y equals negative 9? Still first degree. All right, let's look at some examples of things that are not linear. Okay, so these are linear versus not linear, nonlinear. Okay, how about 2x squared minus 3x equals 9? Most people say, hey, that's degree 2. In fact, it's quadratic. So that's right. It's not linear. And you say, well, why is it important to distinguish between the two? So, because it affects the graph, and that's what we're about to spend a lot of time on is graphing. So in other words, the graph of a linear equation is different than the graph of a quadratic equation, is different than the graph of a cubic equation, etc., etc. So, okay, how about 4y cubed equals 12? Well, it's cubic, third degree. Okay, how about 5x minus 3 root x equals 7? Now, that's a radical equation, right? So if you see a square root, a cube root, a fourth root, something in there, that's a radical equation. So its graph will look different. So we can start to talk about the looks of these various functions. I don't want to use the word function yet, but the looks of these graphs. So, okay, a little more. I'm going to zoom in on linear equations, a little bit more on linear equations. They come in many forms. They wear many hats, right? So ax plus by equals c would be standard form of a linear equation. Most of you are familiar with good old y equals mx plus b, slope-intercept form. Now, if you have no recollection of what the m and the b stand for, well, m stands for slope, and b stands for your y-intercept. but we'll deeply explore that in a moment. Okay, so that's slope-intercept form. And then y equals an arbitrary constant. I'm going to call that k. That's a horizontal line. So if you just have y equals an arbitrary constant, that's horizontal. If you have x equals an arbitrary constant, you have yourself a vertical line. All right. Let's look at the next slide. Oh, actually, I don't want to go there yet, so I'll go to a blank one. Okay, so technically we're not supposed to talk about parent functions until next semester, but I think it's really good to have, I'm going to call these parent functions. It's good to have, I'm going to call it parent graphs for now because we haven't talked about functions. A picture in your mind of what the parent should look like so you know whether your graph is right or not in the end. What I mean by that is the most elementary case, of the linear function, y equals x. That's a line, right? Here's the most elementary case of the quadratic, y equals x squared. So you notice the shape of the graph is like a parabola. Note to self, parabolic. Parabola. Okay? But if your parent is y equals x cubed, the shape will look like, I call it the John Travolta arms, right? You can Google John Travolta and Saturday Night Fever and see his dance arms, but that's the shape of a cubic, okay? If you have y equals square root of x, some people say that's like a shooting star, sort of starts here at origin and emanates out, okay? Let's see, what other parents could we have? I don't want to do too many this term because we're not at the 100 level yet. We're still at intermediate algebra. So the other parent I will do is y equals the, let's go with the absolute value of x. Oops, let me change my stroke there. Y equals absolute value of x. Some people say, okay, that's just a sharp V. So it's not, it's not like this one. This one's bowl-shaped. This one's like a sharp V. Okay, centered at origin. So I'm just going to circle that. That's absolute value of x. And 1, 2, 3, 4, 5. There's one other one. Oh yes, I had forgotten. Let's look at y equals cube root of x. I call that the walk like the Egyptian because the hands look like that, right? So, and I'll kind of circle that as well. Okay, so those are our basic shapes. What's going to happen to us in a moment is we're going to be thrown a random equation and we have to graph it. And at this phase in algebra, all we know is by plotting points and making a table of values. Okay, so now we're ready to begin graphing. Let's start off with just a basic linear equation. 2x minus 3y equals negative 6. So when I survey people in my class, this podcast I'm making just on my iPad in my office, but when I do them live in class, people usually say, hey, let's mold the equation into y equals mx plus b form, which is slope-intercept form, and then, rise and run. So, all right, let's take a look at that. Let's say we want to do that. Get y by itself. Then you'd have negative 3y equals negative 2x minus 6. Divide every little thing by negative 3. And this is just an option for how you may want to graph something. Now we've got negative over negative is a positive, so we've got y equals 2/3 x plus 2. Okay, so here we have it in all its glory. Let me change my color here. We can readily identify the slope. The appeal of putting it in that form is you can identify the slope and you can identify the y-intercept. Okay, so you say, well, why would one want to do that? Well, what we're going to do for starters is we're going to plot the y-intercept and then we're going to rise and run. Okay, so over here I'm just making a rough sketch, nothing fancy. First thing I sketch in obviously is my axes, x and y. Okay, then what I'll do, I'm thinking about my tick marks. I'm going to put a tick mark there, a tick mark there, a tick mark there. Just kind of so you can see my tick marks. 1, 2. Okay. So I have to put a starting point at 2 is my y-intercept. So I always say, all right, let's just put a dot at 2. Then the slope, let me put some more tick marks in here. The slope tells, my tick marks mean 1 unit. Each tick mark is 1 unit. So if it helps you, I'll put some numbers in there. 1, 2, 3, 1, 2, 3, etc. So the slope tells you how to move. Recall that slope is rise over run. So basically, I'll highlight this. 2 is my rise. 2 is my rise. 3 is my run. So from this start point, I'm going to rise 2, 1, 2, and run 3. And I don't know if you can see what I did there. My pen's acting fussy, but okay. So and I'll draw that in red now. What I did was I rise 2, run 3, boom, and now I'm going to connect the dots. I'll do that back in black. So that's one of your fastest ways of graphing a line, is to just take your start point, your y-intercept at 2, and then rise and run respectively according to the slope. Okay. Now let's take a different approach. Let me hit pause. Okay, I changed my graph paper because I didn't like the other graph paper, although this one doesn't have the grid, but it says graph using intercept. So we want to use intercept method. So what if you had 4x minus 3y equals negative 12, okay? Now recall, if you have to find and plot the intercepts, despite how hideous your equation is, here you're dealing with a linear equation, but you can always go with this little mini table, just put zeros respectively, 1 0 in for x and 1 0 in for y. And I always say just go ahead and plug and chug. If you put 0 in for x, what would you get out for y? Some of you can see that. It would be 4. If you can't see it, you could literally write it out. 4 times 0 minus 3y equals negative 12. That's just going to zero out. So negative 3y equals negative 12. And then you can, literally solve it for y. So you'll get out 4. Okay? I'm going to erase that. Now, go ahead and put 0, and I'll pick a different color here. Now go ahead and take this 0 and put it in for y. So we had put a 0 in for x and got out 4. Now let's put a 0 in for y. Well, if y were 0, then x would have to be negative 3 to satisfy the statement. So now what you have is you have 2 key points. 0, 4, let's plot it. It's right here. 0, 4. And negative 3, 0. It's right here. Yeah, this graph paper is definitely better. And then, like I said, just go ahead and connect the dots. So that would be intercept method, by finding and plotting the intercepts and connecting the points. That method is great for linear equations. I don't know that I would use it for quadratics or cubics or something like that, but sometimes it's very useful to know the intercept. All right, let's see what's next on the mental checklist. Okay, so now I'm actually going to throw you a nonlinear equation. So just note to self here, this one's going to be nonlinear. And we'll just talk about stylistically what we can do. And in class I did many examples. For time's sake here on this podcast, I'm only going to do one. So if you have y equals absolute value of x plus 2, some people, they remember, oh yeah, that's just the parent function shifted up 2. So they'll just know, by sheer memorization, what that looks like. But I want to pretend for a moment that I didn't know anything about transformation. So if you know that it's the v shifted up 2, great. But let's, for a moment, let's think about a good old-fashioned table of values. So a lot of people say, what am I going to pick for x? I always say just pick a couple numbers to the left of 0, and a couple numbers to the right of 0. So take negative 3, put it in for x. Absolute value of negative 3 is 3, plus 2 is 5. And just so on and so forth, and keep doing that. Now put negative 2 in for x. Absolute value of negative 2 is 2, plus 2 is 4. See, so I'm just filling out the table. I'll hit pause. So if you're going the good old-fashioned path, you'll fill out your table of values and you'll start plotting the points. So let's try. Okay, negative 3, 5. So when I'm back 3, and you can see, hopefully you can see my tick marks there. It's negative 1, negative 2, negative 3, and then negative 1, negative 2, etc. So I'm just counting the tick marks. So back 3, up 5. So it's going to be right about here. Okay. And negative 2, 4. That's going to be right about here. Negative 1, 3 is going to be right about here. 0, 2 here. 1, 3 is right here. Oops, pen's getting fussy. And when you're at 2, you're up at 4. So what you're noticing is basically you should notice something emerges. What emerges? The shape emerges. You say, well, what shape? Remember we said the parent function is absolute value is a v? So what I'm trying to say is that the correct shape should emerge. Okay? And I know that's kind of hard there because I don't have the perfect graph paper, but this sort of sharp V that we were talking about should emerge. And notice the shifting. We're not supposed to talk about shifts, but notice that it shifted, or transformations shifted up to. From the parent function being located origin, it shifted up to. All right, I just want to give you an alternative path then, which would be to use the graphing calculator, or either that or Wolfram Alpha, but let's go with the graphing calculator for now, because the reality of it is people are going to type this in their calculator, produce the table, and then plot. So I just wanted to show you that. So I'm using the an app, Doceri app, on my iPad so I can operate my desktop, but here is the graphing calculator, and just to kind of pull this down, I hope you can see it, you will go to y equals, and if you want to type in everything that I was typing in earlier, the absolute value graph, you'll go to y equals. To get absolute value, you'll go to math. You'll slide, go to math, go over to slide with the arrow key over to num. You can see it highlighting there. Let me see if I can actually highlight it here with my pen. So you'll see num, highlight num, and then highlight abs for absolute. So you see here abs for absolute value. And I'm just going to hit enter. Okay, and absolute value, I think we said of x, and then we had said +2. And remember, zoom 6 on here is your standard window, so it'll give you a standard window from like -10 to 10, your graph. And it looks exactly like what we graphed when we did it by hand. And I'll just zoom in so you can see that. Okay. Another lovely feature of the calculator is if you hit second table, see table in yellow, it produces the table of values for you. So we had done it by hand, and there it is. So that makes life easy. Okay. Okay, and so if I go back to the frequently asked questions that we had before, how do you graph linear and nonlinear equations? I think let's have our mental checklist here. So we've figured out how to do that. We did it by plotting points, and if you have a linear equation, we've reviewed y equals mx plus b form. So let me just go back through the checklist, graph linear and nonlinear equations. And you even got a little sneak peek at how to use the graphing calculator. Okay. 2, how do you identify x and y intercepts? We did talk about that. We said, I'm just making a little reminder here, to make the little mini table, with the zeros. If you store 0 in for x, you'll have yourself a y-intercept. And if you store 0 in for y, you'll get yourself an x-intercept. So that's just that reminder on how we got x and y-intercepts. And then the final thing that I wanted to look at was how do I calculate slope, distance, midpoint, and actually write an equation of a line. And so I'm just going to write here because we had that earlier. So calculations, that's the next frontier here. Let me pull up another page. Okay, so let's start off with 2 points in space, because we can actually couple this all out in one shebang. So let's have point A be 1, 3, and let's have point B be -2, -4. So there's lots of things I want to be able to perform in terms of calculation. I want to calculate the slope of the line through these 2 points. So, if you're visual and you feel like you need to plot it and see what it looks like, that's fine. But now I just want to look at calculations. So calculate slope of line AB. So remember, you should label this x1, y1 and x2, y2. so that you can, in essence, plug and chug into y2 minus y1 over x2 minus x1. So you definitely want to devote your slope formula to memory. Okay, so then that's negative 4 minus 3 over negative 2 minus 1. Be careful of signs. All right, then you have negative 7 over negative 3, but a negative over a negative is a positive, so we'll just say 7/3. Okay, so that's your slope calculation. Now, I'm actually going to erase that and let's perform a different calculation. So I hope you caught that. If my eraser works here. So now let's go ahead and calculate the distance between those 2 points. So my thing is, once you have everything labeled with your x1, y1, x2, y2, it's very easy to perform all these calculations. So now let's take a look at distance. And again, once you have these formulas memorized, life is good. Okay, so that'll be y2 minus y1, whole thing squared, plus x2 minus x1, whole thing squared. All right, so we're basically going to have negative 4 minus 3, whole thing squared, plus negative 2 minus 1, whole thing squared, and then under the square root. And you can keep cleaning that. You know, that's basically negative 4 minus 3 is negative 7 squared is 49, plus, and then negative 3 squared is 9. So the distance is 58, square rooted. So square root of 58. Now, a lot of people say, well, hey, that's a decimal. That's fine. You can type it as a decimal, but main thing is I want you to be able to perform that calculation, okay? And you should probably think, whatever, you know that the square root of 64 is 8, you know, so it's something in between 7 and 8, 7 point something. And that distance should make intuitive sense if you were to graph this out, okay? Now, the next calculation is midpoint. So I'm just making sure you know how to use all these formulas. So I'm going to erase that one. And obviously you can pause and rewind this podcast, you know, if you get stuck. Okay, midpoint of the line segment AB. So that's another lovely formula. So x1 plus x2 over 2 and y1 plus y2 over 2 will give you the coordinates. So bear in mind that midpoint is a coordinate in space, right? So let's try it. 1 plus negative 2 divided by 2, comma, and then 3 plus negative 4 divided by 2. That's what's going to give us the coordinates, so let's keep crunching that out. So that's basically negative 1/2, comma, negative 1/2. So that's the coordinate in space of our midpoint. Okay, and in class I have people draw that and say, hey, does that make sense? But I'm trying to cut down on the podcast time here. But your midpoint should make intuitive sense. So if you were to plot those points on a grid and see if that midpoint looks like it's cutting the line segment in half, basically. Okay? All right, and final calculation, I promise for today, is actually, now let's go ahead and actually write the equation of the line through those 2 points. And like I said, that's a 2-phase procedure. So we had calculated the slope before. So I just want to talk about, the procedure for finding the equation of a line. Let me erase all this here. It's a 2-phase procedure. You want to calculate the slope, which you already did. So 1, find slope. And let's see, what did we say that was? 7 over 3? Let's see. Yeah, negative 7. Yep. So 7/3 we said was the slope. We had done that a moment ago. And then phase 2 would be plug into point slope form. Y minus y1 equals mx minus x1. You want to plug into there, and you'll get your answer. So this would be for finding the equation of the line AB. So find an equation of the line AB. Okay, and the end game is to get to y equals mx plus b form, but we have to plug certain things in. So I always tell people, let me do this in another color. So you're going to plug something here, here, and here. You're going to plug in your y1, your x1, and your slope. Okay, so let's actually do that. So phase 3 then, we'll say. Y minus 3 equals 7/3 parenthesis x minus whatever our x1 was, which, you had pre-labeled. Okay? You arrive here on a test, you got yourself 3 out of 5 points. Then all you got to do is clean it up and get y by itself. So I'll hit pause as you distribute that. So y minus 3 equals 7/3 x minus 7/3. And then just move 3 to the other side and take it from there. So what will that be? 2/3. So I'm just going to write the final answer up here. So final answer would be y equals 7/3 x plus 2/3. All right, hope that helps.